Some people have asked for a little bit more review on pyramids. It seems like that is one thing that's throwing people off. So I have this worksheet that we did with people who came in SRT. You can just pause this and work on it and listen as I go through it, or watch me go through it, but try to work out the numbers yourself. So this is like a sample IB question that they come up with different points. So state the number of faces. That's the triangles around the outside. And so that answer is just 6. The vertices are all of the points plus the top. So that'd be 6 plus 1, which is 7. And the edges, there's 6 edges here, and there's 6 edges around the bottom. So 6 plus 6 is 12. So that's just kind of general background stuff. All right, so let's now define the other information that we have. Let's put it on our picture. So we know the length of each of these sides is 6. It's a regular hexagonal pyramid, and it's the vertical. It means it's a right pyramid. It's directly above the center, and then the height of the pyramid is 10. So find the volume. Look up your formula. Volume of a right pyramid. It's 1/3 the area of the base times the height. First thing is get that formula down, and let's find out what we know and what we don't know. So we don't know the area of the base because it's a hexagon. We're going to have to figure that out. We know the height's 10, so you have at least that much. So to find the area of a hexagon, we want to remember that a hexagon can be divided up. Any of these regular polygons can be divided into triangles. And so there's 360 degrees all the way around divided among 6 triangles. That means that each of these angles is 60. So if I take out one of the triangles, and this is 60, and I know this is 6, it's an isosceles triangle because these are regular. That makes that like a radius. So that means the other 2 angles have to be 60. And so what we really have is an equilateral triangle. And so I have a side, an angle, and a side, so I can use my area formula. Area equals 1/2 AB sine of C. So this is the side, the angle, and the side in between. So 6 times the sine of 60. And you really have that all 3 sides. You can use any way you want. And so the area of one triangle, 1/2 6 times sine of 60. Put in your calculator.
Kathleen Marquez to the main office, please. Kathleen Marquez to the main office.
That is 15.6. So there are 6 of those. So I'm going to take that number times 6. And I left the exact number, but 93.5. So to finish that volume, you're just going to multiply that out. You get about 312 cubic centimeters. So then I'm going to erase this. So then we switch to find the total surface area of the pyramid. Well, that has the hexagon plus the 6 faces. And we said the hexagon was 93.5. That was those 6 triangles on the bottom. So now we need to find one of these triangles on the side. And so this is 6. I know that. I can find some parts of this triangle by making a right triangle with this middle little radius looking thing there. Because I know that bottom is 6, and I know the height is 10. So if I take that triangle out, this is 6, and I know this is 10. That was given. I can do Pythagorean theorem. So 10 squared plus 6 squared. So that's a square root of 136. Okay, so if I have that tall, skinny triangle, there's 6 of those. The bottom is 6, and both sides are the square root of 136. Well, I don't have side angle side yet, but I can find this angle using either sines or cosines. It's not a right triangle. So I'm going to ask myself, do I have an angle side pair? Which I don't. So that means I'm using law of cosines. So if I call that C, the cosine of C equals the two sides on either side of it, squared, minus the side across from it squared. So A squared plus B squared minus C squared over 2 times A times B. So I'm going to simplify that and do second cosine so I can get the angle C. So you do that in your calculator. Go ahead and do that in your calculator. Pause it. Do your calculator. You get about 29.8 degrees. So with that, now I can find the area of this triangle because I have a side and an angle on the side. So area is 1/2 radical 136 times radical 136. It's not going to show up there. Times the sine of 29.8. And so I have to multiply that answer by 6, but I'm going to go ahead and find it first. So 0.5 times the square root of 136 times the square root of 136, which is just 136, times the sine of 29.8, which is 33.8 for one of these faces. Take that times 6, you get 202.76, some other numbers. But I need to add 93.5 to that because that's the base. So you get about 296. Depends on where you round it. I'm not going to worry about the rounding as much on this. So that's the total surface area, which is the hardest question, I think, to figure out usually because there's so many parts to it. Okay. And the last one here is also a little bit tricky. It says determine the angle between AFG, or determine the angle between face AFG and the base. So AFG, which could be any face, and the base. So I'm going to draw it. I think it's easier to see it right there. Uh-oh. So we're talking about this angle right there. It's hard to do this with the touch screen. So I know that's 10. And I need to figure out one of the other two sides. Won't stay on there. So it's up to you how you do that. Probably the hypotenuse is going to be the one that's easier to find. You can also find the base. It doesn't really matter how you decide to do that, but we know that. I'm going to try to erase this. We know that any one of these edges is the square root of 136. And so if you make a right triangle with the middle of, this is not easy to write on this tiny thing, sorry. If you make a right triangle with the midpoint of a side, that's 3, and the hypotenuse is a square root of 136. So it's really this thing. You can find that side. Okay, so I know the picture is hard to tell. then that is the middle. There, maybe I colored in, it's easier to see. Not really. 3 squared plus b squared equals square root of 136 squared. And that's going to give you that middle, and then you can go back and plug it in. Okay, this is a picture is a mess, so I'm not going to keep doing that. You end up getting 62.5 degrees. What I've told people in the class, I go, this is a little bit beyond what we're doing right now. But if you want that as a challenge, you can do that. Okay, so that's the first question. Remember to always divide your regular polygons into triangles so you can figure out the angles. We're not going to do this without a regular polygon unless it's a rectangle, and that's a lot easier. Okay, so the other thing is that I will pause this right here. You can pause it, and if you want to check the work, you can. You can follow some of their work. They're showing how they get that one side. You have to do second sign at the end. Okay, the second one is a square-based pyramid, and we know it's a right pyramid because it's directly above. So we're going to find some of these different things. So I always check, both of the given pieces of information are on the picture. So we can just go right down to answer these questions. So calculate the angle between the line AE and the plane face, so the bottom. So that we're talking about this triangle and this angle. So I have to see, what do I know? I know a hypotenuse is 20. And I need to find either the height of that pyramid or that bottom piece. Well, I can find the bottom piece because the bottom of the shape is a square. And so I can find all the way across and then use half of that for my triangle. All the way across is 16 squared plus 16 squared. I can take that and divide it by 2, and I'll get that bottom piece. Okay, so when I divide that by 2, take square root, blah, 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 I get 11.3. Don't just take my word for it. So to find the angle, the cosine of the angle I'm finding is 11.3 over 20, which means I have an angle of 55.6 because I did second cosine. Okay, second question, calculate the angle between the face, so BCE, which is that right triangle there, and the face ABCD, which is the bottom. So we're finding a right angle right here. We're going to use that right triangle. So for that one, things I know that this is 8, because it's halfway, and I can find the other side. Somehow I have to use a solver there. Well, I can take a look at this right face, and I found this edge last time. So that edge was 20. It's given, sorry. And so if that's 20 and this is 8, which is halfway, those are both 8. It's pretty hard to see with that small triangle. I'll draw it out here. So this is half of one of those faces. This is 8 and this is 20. I can find that height. I can take 20 squared minus 8 squared. And the square root of that, which is about 18.3. So So that's 18.3. So looking at that triangle, I have, again, the bottom is 8, and the hypotenuse is 18.3. That's, again, a cosine question. So this time it's the cosine of 8 over 18.3 is my angle. And that ends up being 64.1 if you put it in your calculator. So I got 55.6, 64.1. Always kind of keep track of those things because you might use them again. I'm going to erase this off my picture so I can clean it up, but you might just leave it on your picture. So calculate the angle between the line AE and the line EC. So AE and EC. I'm just going to make one big triangle there. And so I know that both AE and EC are 20. And way back in the beginning, I found this, and I took a half of it. It was that 16 squared plus 16 squared. Only this time, I'm not going to take half of it. So 16 squared plus 16 squared is 512. So this bottom side is the square root of 512. So if I need to find angle E, I'm looking and I'm saying, do I have everything that I need? Well, I can't do sines because I don't have an angle side pair. It's not a right triangle unless you make it into a right triangle, and basically you're reinventing one of your properties. But if I have three sides, I can do cosine rule. So I can find the cosine. You can call that C if you want. It's the two sides squared minus the bottom squared all over 2 times the two sides. Okay, and again, I'm going to let you pause and solve it because that's not what this video is for. If you need help on that, go back to the law of cosines video. That angle is 68.9. And if they ask for the other two angles, you could subtract those from 180. Those are equal. It's an isosceles triangle. Find the volume of the pyramid. The volume of the pyramid is 1/3 the area of the base times the height. So the area of the base is a square, so it's 16 by 16. And the height, we haven't found that yet, but we can easily find that. We have a whole bunch of right triangles that we've been using. So I go back to my picture, and it doesn't really matter which way you go with it. I'm just going to use this one. So back in the original part of the problem, we found this bottom piece was 11.3. And the hypotenuse is 20. So 20 squared minus 11.3 squared. Take the square root. So the height is 16.5. So plug it right in there. So I got the height now. I got pretty much every side I found at some point or another. Multiply that total thing out, you get about 1410 to 3 sig figs. And then it says find the total surface area of the pyramid. So let's look at what we found and try to use some of that. So total surface area of the pyramid, first of all, we need to find the area of the base, which is a square. So 16 times 16. Plus I have 4 triangles. And these triangles, I know some stuff about them. I know that the sides are 20 and the base is 16. So I don't have a side angle side that I can use. I could use cosine rule to find that angle. Did I find a base and a height? So I also know the base is 16. The height is that line that we found going down the middle of the side, which was I think in part B, we found that to be 18.3. So that's this measurement right here. So I can do the old triangle formula, which is 1/2 the base times the height. So I have 4 of those triangles. So I have 16 times 16 for the base plus 4 of those triangles. Again, there's other ways to solve that. That's probably the easiest way to get that. If you wanted to get this top angle, you could, and then you could do your 1/2 AB sine C. You'd have to use cosine rule to get that angle, if you like that area formula. When you multiply that out, add them up, you get about 843. I think if you round, you get like 841.5 as you go. So those are definitely some harder questions. I'm going to move this up so you can see the answer key. But it gives you a chance to practice if you're done with everything else and you want to try some challenging ones. Those are good ones. Also, back on Canvas, there's a link to all those other practice videos that would help you as well.